Let's look at what it means to have an infinite limit, which is not really precise, it's just the notation we use to indicate a particular behavior. So when we write the limit as x approaches a of f of x equals L, we could also write that as the limit, or sorry, not L, I apologize. These are infinite limits, so not a particular number, but infinity. Clearly can't equal infinity, it just indicates a certain behavior. We could also write the limit as x approaches a of y equals L, or we could use more of a narrative as x approaches a y, or f of x, approaches infinity. Now we can't really approach infinity, so this is where the definition gets interesting. Let's draw a picture of an example. So here's a picture indicating that as x gets close to a, the function value y gets close to infinity. Close to. Alright, so what does this mean? It means something like choose the biggest number, literally a number, you can. You can choose the biggest number you can think of. Pick one. And I don't literally mean the biggest one you can think of, because clearly if you choose one, it's not the biggest you can think of, just add one to it. But you get my point. Choose a big number. Let's name it. Let's call it uppercase N. My daughter insists that I call big letters uppercase. Then, if I choose some big number, N, let's name it like right here on our graph as our y value. Some big number N. You can already see where I'm going with this, right? The y values are eventually going to surpass this big number. Okay? So give me a big number. I'll put it here as a y value that I'll try to reach. I'll make it my goal. Then I will come up with a delta neighborhood. Sorry, not really too focused here. A delta neighborhood of A such that the image of every x value in that delta neighborhood of A, any x value in that neighborhood, the image of that is bigger than N. Okay? Alright, well, let's get busy here. So how in the world, you give me some random large number N, how in the world can I find a delta to create this neighborhood so that if I look at the image of that neighborhood, everything's going to be bigger than N? So here's the idea. Let's take a look at this N a little closer. Alright? Let's figure out where this function equals N. Well, right there it does, so that comes from this x value down here. Okay? And it also equals N right here. So I drop that x value as well. It's kind of hard to draw this small on here, but you get the idea. So clearly now I want to choose my delta neighborhood to be inside this, because don't you agree, any x in this region will result in only y values up here, and those y values are bigger than N. Now delta is a particular number, so when I say a delta neighborhood, that means the same delta left and right. It's like the radius of this neighborhood. So I'm going to choose my delta to be the smaller of these two distances so that I know it's going to be contained inside there. So this will be delta, this will be delta. And then our delta neighborhood, let's say the right distance, this guy here, is a little bit smaller. So delta is going to go all the way to this original x value. Over here it's going to come up just a little bit short, let's say, just for illustration purposes. And now you can see if I trace this neighborhood all of those x values are going to trace up here. So I'm going to result in a y value here that's bigger than n. And this guy, of course, is going to trace back up, since it's right on n. It's going to trace back up to here, which goes right back to n. And so everything here above is bigger than n. And now I've come up with this neighborhood. And the point of this is, no matter how big you choose this n, I will choose a neighborhood sufficiently close to A so that every x value there has an image bigger than this large number that you chose.